Hi again, here is the rest of the notes for quadratics and graphing. The other way that you can see quadratics expressed is in vertex form, and this is even easier to graph from than standard form. So your vertex form looks like this: y equals a times x plus or minus h quantity squared plus or minus k. And so we've seen this form throughout absolute value and also radicals. And the good news is that the same rules that we discussed in absolute values graphs and radical graphs still apply here. It's all the same. So if you have x minus h, that means you're going to go to the right. If you have x plus h, you're going to go to the left. If you have a plus k, that's going to make the whole graph go up. If you're going to have a minus k, that's going to make the whole graph go down. If the absolute value of your a is greater than 1, you're going to have a stretch. If the absolute value of a is less than 1 but greater than 0, you're going to have a shrink. And then, of course, if a is positive, you have a face-up graph, and if a is negative, you have a face-down graph. So all those rules that we have been studying throughout the other units still hold for quadratics. That's the good news. So all we have now is just a different shape to graph. It's going to be a U-shaped graph instead of what our other curves were. So starting with this example right here, you have x minus 3 quantity squared minus 5. There's really a 1 in front of that. So this x minus 3 tells me I am going to go to the right 3. And the minus 5 tells me I'm going to go down 5. So I go right 3, 1, 2, 3, and I go down 5. 1, 2, 3, 4, 5. That's where my vertex is going to be. So the coordinates of my vertex will be 3, negative 5. Well, if my vertex is 3, negative 5, then my axis of symmetry has to go through the middle of my parabola. So that's going to be a vertical line, x equals 3. So it's a whole lot easier. You don't have to do any formulas. If you remember those rules, this can be even easier to graph than standard form. So the last thing that we need to do is a table of x's and y's. And this positive 1 here tells me that it's going to be a face-up graph. We just don't know how wide it's going to be. So a table of x's and y's will help us out with that. And we'll just do a couple points on either side of the vertex. So let's see, we're at 3. So how about we do, let's do 1 and 0. And then let's also do 4 and I guess 5. Okay? So it doesn't really matter what points you pick, as long as you get a couple over on the right-hand side and a couple on the left-hand side. So now we're going to take the x coordinate, or the x value, and plug it in to the equation. So this would be 1 minus 3 quantity squared minus 5. And that's going to be, let's see, that'll be negative 2 squared, which is 4. 4 minus 5 is negative 1. So we're going to be over 1 and down 1. So we'll have a point right here. For 0, it's going to be 0 minus 3 squared minus 5. Well, this will be negative 3 squared, which is 9. 9 minus 5 is 4. So 0, 4. 1, 2, 3, 4. Okay? Now, we do the other side. 4. Put a 4 in wherever you see an x. 4 minus 3 squared minus 5. So 4 minus 3 squared, that's 1. 1 minus 5 is negative 4. So at 4, we're going to be down 4. I didn't pick symmetrical points this time. Now for 5, 5 minus 3 quantity squared minus 5. So this would be 2 squared, which is 4. Yes, 2 squared, which is 4, and then 4 minus 5 is negative 1. And I guess this one is symmetrical. So over here at 5, you're going to be at negative 1. So these 2 points are actually reflections of each other. These two are just different. So from there, we're going to make a nice U-shaped curve. Make it as smooth as you possibly can. and there's your parabola. Let's talk about the domain. We know that the domain is going to be from negative infinity to positive infinity. Your range for this, since it's face up, is going to be from negative 5 to positive infinity. Why negative 5? Because it's the y coordinate of the graph, up to positive infinity. And then this new thing is called end behavior. The end behavior is what the ends of the graph are pointing towards. And the ends of the graph here are pointing up. So that means the end behavior goes up to positive infinity. So to write that, you're going to say as x approaches negative infinity, y approaches positive infinity. So what does that really mean? That means as you go to the left, your graph goes up. And then the second half of end behavior will be as x approaches positive infinity, y approaches positive infinity. This is the formal mathematical way to do end behavior. So what does this mean? This means as you go to the right, your graph goes up. So as we go out to the left, farther and farther to the left, your graph goes higher and higher up. For the other side, as you go to the right, farther and farther to the right, your graph goes farther and farther up. That's what this end behavior means. So let's do the last example, and then you can try some on your own. Let's do this one together. So this is a negative 1, x plus 4 quantity squared plus 1. So the plus 4 tells me I'm going to the left 4. The plus 1 tells me that I'm going up 1. So we're going to go to the left 4, 1, 2, 3, 4, and up 1 right here. And so since this is a negative 1, I know that my graph is going to be face down. So we'll use a table of x's and y's to help us get a nice graph for that. So my vertex, though, I can label that. That's going to be negative 4, 1. My axis of symmetry is going to go right down through the vertex, and that's going to be the line x equals negative 4. Okay? So this is my axis of symmetry. This point right here is my vertex. Okay, so let's do a table of x's and y's. So we need a couple of points on either side of negative 4. So let's do negative 2 and 0, and let's do negative 6 and negative 8. Okay, so we're going to plug it into our equation. Negative 2 plus 4 quantity squared plus 1. So this is going to be 2 squared, which is 4. Negative 4 plus 1 is negative 3. So negative 2 and negative 3. 1, 2, 3. Go down 3. For 0, it's going to be negative 0 plus 4 quantity squared plus 1. So this is going to be a big number. So 16, negative 16 plus 1 is negative 15. I might not have enough spots for that one, but we'll estimate. So 0 and then down 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's way down there. Okay, just make a few extra points. For negative 6, it's going to be negative 6 plus 4 quantity squared plus 1. Okay, well this is negative 2 squared, which is 4. Negative 4 plus 1 is negative 3. So at negative 6, 1, 2, 3, 4, 5, 6, we're going to go down 3. 1, 2, 3, right there. For negative 8, that's going to give us that big number again. It'll be negative 8 plus 4 squared, and then plus 1. So that's going to give you negative 4, which squared is 16. Negative 16 plus 1 is negative 15. So you're going to go down here, and I'm going to try to make it, it's kind of like in my other table, right about there. So 1, 2, 3, 4, 5, 6, 7, 8. and then down, so it's in line with this one. So we're going to have a face down parabola. Try to make your curve as round as you can, like so. Make that a little bit nicer. And there's your parabola. Your domain for this will be negative infinity to positive infinity. Your range, now this one's flipped upside down, so your range for this one will be negative infinity up to 1. And your end behavior will be going down to negative infinity for both of these, down to negative infinity. Okay, so this is a quick video on graphing. Try the exercises on page 3 and 4 and show me, and hope this helps.